Hello, it's Dr. Clark here again. Going through some Labchart tutorials. This one is looking at interrogating channels by adding channels, which will include a summary calculation. So we've got the dynamic exercise data here, continuous data over about 22 minutes. Here we are looking at incremental exercise where we've measured blood pressures, heart rate, and tidal CO2 and O2. Saturation and respiratory flow. For this instance though, we're going to concentrate on CO2, and maybe at the end we'll look at O2 as well. So we're going to start by just having a quick close look at the CO2. So here are the CO2 measurements taken from a Servomex. We look at these in other tutorials as well. So here we are, the individual peaks. If we wanted to summarize these numbers by reporting them as a mean end tidal CO2, for instance, at the end of a protocol for the last 10 seconds or throughout the protocol, we could do it by simply holding our mouse over each of these points and making a note of the number that appears in the top right here. We could drag a little DVM window and we could copy it down onto a piece of paper or type it into Excel, and we could get our end tidal CO2s very accurately. It would be accurate, no doubt about it. It would also be probably the most time-consuming job you've ever done, because we've got a lot of breaths here over a lot of time, and it's going to take you a very long time to go through the entire protocol, writing down all of these numbers, and the risk of any typographical errors or misalignment or something is quite high, owing to the amount of work that's involved. We could, as we've discussed in other tutorials, use Datapad. Datapad's very clever in that it'll summarize variables for you and take the peak heights and things like that, which is very useful. However, with Datapad, the one thing it doesn't do, and this is a caveat that must be fairly clear, is it doesn't give you a visualization of what it's doing to the data. So it may be taking a mean over 15 seconds, but if there are any odd numbers, any abnormalities in the data set, like this one for instance, we've got some nice end tidal CO2s of around 5%, and then suddenly right in the middle here we've got an end tidal CO2 of 2.5. Clearly the subject took half a breath or half a breath out and then took another breath in and then breathed again. So you may not want to include this in your end tidal CO2. We probably would, because it is after all a breath, but if it was another kind of measurement and it was just a kind of a noisy peak, the Datapad system would just take that into account and average that, so you may end up with some anomalies in your data. So with the system we're looking at now, we're actually going to get a visualization of the end tidal CO2, a graph showing it, and then you can obviously look at the data and interrogate it quite nicely using that. So let's close down that, because we're not going to be typing out all these numbers. What we are going to be doing is adding another channel. So we go up to the setup menu and choose channel settings, or press Ctrl Y on the keyboard, and it brings up this window which we've seen before. It gives you a list of all the channels. We've got 7 channels that have been recorded here. Of course we're not plugged into a PowerLab system, so we can't edit any of the sample rates, etc, etc. But what we can do is we can add another channel. So I'm going to choose add one, so now we're on 8 channels, and funnily enough, because I've been playing with this, it says end tidal CO2, but you can type anything you want here. So end tidal CO2 we've got written in there, and over on the side here you can choose between any one of these calculations, mathematical calculations. You can do a simple arithmetic calculation, and we may look at this in another tutorial. You can just simply add numbers to all of your data set. You can look at cyclic measurements, so rates, minimum, maximum, things like that, which we will be looking at. You can look at derivatives, you can add filters, you can do integrals, shift, smoothing, etc. And these are some of the plugins I've got installed on my version of Labchart. So the standards are the top ones here. So we're going to choose cyclic measurements because we're going to be measuring cycles using the CO2 channel. So the window looks a bit complicated, but actually is very simple. You've got the setup, so where the source is coming from and what it's measuring. You've got the output, so where is the data going. You've got an example of the data set in the middle here, and you can interrogate that just to make sure that the parameters you set are correct. You've then got the detection settings and the detection adjustment, and this is what picks up the various things you want to be looking for. So let's start from the top, and we want to choose CO2. And it's automatically flipped to rate. That's the default. We don't want to measure breathing rate, although of course you'll notice that we can very quickly set up a channel to measure respiratory rate just by using this window. But we're not going to choose rate, we're going to choose maximum, because we're going to look at end tidal CO2. So there we are, we've chosen maximum, and you can see a selection of our data here where the computer has looked for the maximum peak every time, and it's done a fairly good job. Look at the output very quickly. Let it auto scale, that's the safest thing to do. And decimal places 4. Well, we don't want 4 decimal places, that's just ridiculous. So let's just choose 1 decimal place. There may be an instance where you want to actually mark every breath on your chart recording. You may think that's a very strange thing to do, but there may be situations where you would want to do that. If that is the case, you can click on the event markers box, and we're going to come back to that I think later on and just have a quick look at that one. Okay, looking down at the detection settings now, it's got a load of presets that came with the software. The default is general sine shape, and of course the respiratory trace isn't actually a sine shape, although in this instance it's done a quite good job at finding some of the peaks. But you'll notice here, for instance, it's completely missed a peak because it's trying to match it to a sine wave. And we've got a choice. We can choose thresholds, peak after threshold, sine, spiky square, etc., etc. And right down the bottom here is respiration airflow, which is what we are actually measuring. We're measuring airflow. So immediately you can see now they've moved ever so slightly, and we're a little bit closer to picking up the little pink peaks here. And you can also see it's actually picked up a few of the half breaths that I was having a whinge about earlier. So let's have a look through that. That looks okay. However, on closer inspection you can see that the little peak it's put in here isn't actually on the end tidal. That's probably because maybe the flow isn't quite what it expects. And if that's the case, we can click on the Customise button here, and again it brings up a rather complicated window that in fact is very simple, and in fact it's going to take one click for me to solve this problem. What Chart tries to do is it tries to smooth your data to make it a little bit cleaner. It's very nice for it to do so, but unfortunately it sometimes smooths out the data that you're actually trying to measure. So if I turn off the smoothing, which is in the general settings here, immediately you see our data set is now matched very well, and you can see at the end of each of these end tidals it's picked up the end tidal measurement of CO2 incredibly accurately. So let's just look at this window very briefly. We've got the mode of measurement, so we've chosen that we're measuring a general measurement, which is what this is, and I've turned off the smoothing. We can add a filter to it. We wouldn't want to add a filter to this kind of data, but we could do. We can normalize it. That's probably a good idea. We just want to make sure that the data is on the screen correctly so we can read it. We don't need to do anything with peak heights or detection because in this instance it's very, very good and very accurate. You may actually want it to ignore small peaks, so we can change the setting here to try and ignore small peaks, and there we are, we've adjusted that, and now the small peaks have disappeared. However, that is kind of cheating because you're ignoring any end tidal CO2s of less than a certain amount. So let's put that back in again and bring that peak back. There we are. So you can see these little wiggles like this don't appear as a peak, but the peaks that are definitely respiratory flow peaks now appear as peaks, which is great. And you can leave this as it is. The rest of the settings you can leave as they are, and press OK. You may get a warning up when you click OK telling you that the settings you've currently selected may produce dropouts in the data, and that's simply because your detection settings are set to such a level that there may be small areas of your data recording where you don't have any peaks, in which case it won't give you a number. But that's fine, just say OK if you get that message. There we are. Cycling measurements output may be discontinuous using the current peak search window. Just say OK to that, it's absolutely fine. So now we've got our 8 channels set up, we can press OK, and there we are down the bottom here, end tidal CO2 appears as a little window. So let's just make him a little bit bigger and make that a little bit bigger, and then we'll scale this to roughly the same scale as our other window just so we can have a quick comparison, and we can zoom out. So now what it's doing is it's plotting end tidal CO2 from all of the peaks in here, and it's trying to remove any noise that might be there. And in fact, if we look at it, it's pretty good. Let's go and find a point where it's doing some strange things. Here we are. We've got a little peak here, some little peaks there, a little slope where the end tidal is dropping down, another little peak, a little slope again, a little anomaly here. You can see it's recorded the anomaly. It's then going up, coming down, leveling off, and you can see the end tidal CO2 is plotting very nicely with the end tidal CO2. it's plotting it for some reason to 2 decimal places, and I'm pretty sure I asked it to do to 1, so I'm just going to check in the cyclic measurements. It's gone back to 4 again, so let's click that back to 1 and say OK, and now we should have 1 decimal place in our window. So now you can treat these data in the same way that you'd treat any data in Datapad. So you can select an area of data and you can add those data to Datapad, and it'll give you the mean end tidal CO2 for a given time point. So that's how you do end tidal CO2. It's nice and easy. Let's just look very briefly at end tidal O2, and the reason I want to do this is there is a slight problem with this software. There's a bug, and I'm just going to point out that bug. So here's our end tidal O2. We don't need to zoom in and have a look at it. You can see it's end tidal O2 with a peak at around 21, and then we've got the troughs here, 14, 15, 12, whatever percentage, indicating this person is doing some exercise. So what we're going to do is we're going to add another channel. So we're going to set up channel settings, add another channel, channel 9, and we're going to call this end tidal O2, and we're going to choose cyclic measurements again. I'll go through this fairly quickly. The source is going to be O2, and our measurement is going to be minimum. Okay, we've absolutely definitely selected the word minimum here, and we're going to zoom in, and look what it's done. It's selected the maximum. Even if we go down here and choose respiration, it still selects the maximum. This is a bug in the software. I've reported it a few times, and hopefully they'll fix it in an update, although I've just updated this morning and it's still broken. So let's choose decimal places 1 again. So to fix this problem and actually get the end tidal O2s, which should be on this peak down here, you can go to Customise, look through the window, and lo and behold, down the bottom here where it says detection parameters, it says trigger maximum. We clearly selected minimum in the original, so we'll click that to minimum, and we'll turn off the smoothing, and lo and behold, now we're measuring end tidal O2s at the minimum of the peak. Press OK again, say yes to the error message, and up you come. And now, hopefully, if we show these 2 data sets on the screen at the same time, and zoom out a little bit just to make it a bit clearer. Yep, that's looking pretty good. You can see here we've got end tidal O2s which are tracing very nicely with the end tidal O2s of here, and if I just select a small area and go into the zoom window and overlay them, you can see there this is tracking quite nicely with the end tidal O2. So that's a quick summary of how to set up end tidals. Of course you can apply the same to pretty much any parameter by measuring cyclic maximum, means. You can measure pulse pressure from blood pressure values using the same add channel, and I would advise doing this. It does take a while maybe to do 5 or 6 of these in a row, but I would advise doing it simply because you can then look at these data and go, yep, the data look nice and clean, there is no strange spiky bits, there's no errors, and then you can select areas and take averages. So that's that.